Gyroscopic instruments include the attitude indicator, the heading indicator, and the turn coordinator. These are considered gyroscopic instruments because each one relies upon a gyroscope to function. They can either be driven by air suction or electricity. These instruments
They can either be driven by air suction. Can you see the buckets over here? Right? Can you see the buckets over here? Can you see the latitude nut? Can you see the latitude nut? Is it over here? Is the latitude nut here? No, it's not here. Right? I wish I could show you the jet also, but here it's not visible. Okay. The electric gyros look kind of like this. They work like a CD machine. Compact disc CD DVD player hota na वैसा.
provide the pilot with such things as their pitch, bank, yaw, and heading. Before we get into each instrument, let's talk about what a gyroscope or gyro is and how it works. In its simplest form, a gyro is a heavily weighted spinning disc that is able to maintain its position and orientation. Gyros operate based on two principles: rigidity in space and precession. Rigidity in space refers to a gyro's ability to remain in a fixed position in the plane in which it is spinning. By mounting the gyroscope on a set of gimbal rings, the gyro is able to rotate freely in any direction. Thus, if the gimbal ring rotates, the spinning gyro will remain this.
आप समझे gimbal ring कैसे काम करता है? Now do you understand how does the gimbal ring work?
Same plane in which it was originally spinning. The other property of the gyro is known as precession. Precession is the tilting or turning of a gyro in response to a force. For instance, a small force is applied to the gyro whenever the airplane changes direction. However, instead of the gyro responding at the source of the force as expected, the result will instead occur 90 degrees ahead of that point in the direction of rotation. What this means to you is that sometimes the instruments may have some unwanted errors, such as a slow drifting and minor erroneous indications in the instruments. The good news is that all gyroscopic instruments have what this means.
Last day we studied about the DGI, the directional gyro indicator or the heading indicator. Now look how is he going to cage the gyro, turn and set it again. So we all know we have studied about the earth rate. What was the earth rate? Earth rate was a slow drift. It was a slow drift because of the rotation of the earth. It was an apparent wander. What do? We look at the compass, we put it in and then we correct it again. He's going to do it right now.
Means to you is that sometimes the instruments may have some unwanted errors, such as a slow drifting and minor erroneous indications in the instruments. The good news is that all gyroscopic instruments have ways to either automatically or manually correct for this precession error. In order for gyroscopic instruments to work, the gyros have to spin at a very high speed. As previously stated, the instruments can either be powered by air or electricity. For safety reasons, different instruments are powered by different sources so that if one source fails, the other source will still work. The attitude and heading indicators are typically powered by air, and the turn coordinator powered by electricity. The spinning of the gyros with air is accomplished not by blowing, but sucking air around it. A vacuum pump connected to and powered by the engine draws filtered air from the...
As you can see over here, the gyro here is vertical. The reason I'm showing you the entire video is that this video will help... Excuse me. This video will help you visualize the artificial horizon as well. The artificial horizon that we are going to study today has a vertical axis, right? Please have a look at the working.
Cabin through the instruments, spinning the gyros, and then dumps out the air into the engine compartment. Let's look at some of the different instruments that use gyros. Attitude indicator.
Okay, now quick question, write down. What is attitude? What is attitude? The artificial horizon is the name of the instrument. Okay, and what does it indicate? It indicates us the attitude. What do you mean by attitude? Harsh, attitude hai apne? Attitude matlab सीना चौड़ा होके चलना, chin up high and doing this, right? So basically attitude is again the pitch, chin up, pitch. Attitude means pitch and roll, bank. Pitch and roll, or the pitch angle and the bank angle together make up the attitude of the aircraft. So what does an artificial horizon give us? Does it give us pitch? Yes. Does it give us bank? Yes. Does it give us anything else? No. Okay. What does it give us? Pitch and bank, nothing else.
An attitude indicator is an instrument used to inform the pilot of the orientation or attitude of the aircraft relative to Earth. It indicates pitch, which is the fore and aft tilt, and bank or roll, which is the side-to-side tilt. Through the use of an artificial horizon.
Now, this artificial horizon kind of looks like this. You can see an outer circle kind of like this, right? That is the fixed card, okay? That is the fixed card. This is an unimmovable card, okay? You see this red thing? This red thing is attached to the glass of the instrument, and it is called the gull wing. It is called the gull wing, Gullwing, gull wing. It is attached to the glass of the instrument. It is not attached to the gyro. So basically, if the aircraft moves like this, the gull wing will also move like this, but the gyro will remain where it is. On the other hand, the card that you see behind that, you know, the circle that you saw, the outer circle, and between that you have the inner circle, the middle circle. This middle circle is a card. This middle circle is a card. And this card can move up and this card can move down based on the movement of the aircraft with respect to the artificial horizon gyro. Okay, if the card moves up, what will happen? More of the ground will be shown. If the card moves down, more of the sky will be shown. By doing this, can I indicate pitch? Yes. Can you look at this part over here? So when the thing turns, using this, we can indicate bank. Okay. So as you can see over here, if this gull wing is at this small black line, it is indicating 5 degrees of pitch. If it is at the big line, it is indicating 10 degrees of pitch up. Similarly, it's in the bottom as well. 5 degrees pitch down, 10 degrees pitch down. Okay. Over here, if this arrow indicates to this line, which one? The one that is next, left to the center one. Okay. Now the one which is in the center of the screen now. Okay. जिसके और black वाली line cross करी, that is 10 degrees of bank. उसके बाद वाला is 20 degrees of bank. उसके बाद वाला is 30 degrees of bank. This is 60 degrees of bank. And my friends, this is a 90 degree of bank. Now let us see when an aircraft actually banks. In this entire scene, you not only have the artificial horizon, we are artificially creating a horizon with the help of a gyro. We not only have the artificial horizon, but we also have the original horizon, the actual Earth's horizon. This video will now tell me how does my aircraft move and how does my instrument also respond to the movement.
And miniature airplane, the instrument depicts the position.
Now forget the instrument. Look at the behind scenario. Look at the behind scene. What do you think by looking at the behind, the clouds and the ground? Are you pitching up? Are you climbing? Yes. And where the horizon is tilted kind of like this. The horizon is tilted kind of like this, from up left to bottom right. So what does this mean? You are banking to the left. You're turning to the left. That is why you can see more dharti, more ground on the left hand side and less ground on the right hand side. That means your right wing is up, your left wing is down. You're turning to the left, right? And the same thing is shown on this instrument. The needle, the gull wing is up. And the horizon is tilted to the left. Now we don't want to see what bank it is. Cool, look at this. This was the main one, this. The one on the right, this. The one on the right hand side of the black line, right? ये देखो, इधर जो अभी आपको 8 दिख रहा है ऊपर, 8. ये देखो ऊपर एक छोटा सा गोल आया होगा, ये वाली line. This was the original central line. Now this is 10 degrees of bank to the left. This indicator is giving me 10 degrees of bank to the left. I am somewhere in the middle and it is showing me approximately 16-17 degrees of bank to the left. Okay, if it had been here, it would have been 20 degrees bank. Cool.
Of the airplane in relation to the
Now, am I at level flight? Yes. My pitch is at 0. This is how a left bank looks like. I am at 20 degrees of bank to the left. And where is my pitch? My pitch is on the horizon. My nose is on the horizon. As you can see, the same thing outside as well. How do I know I'm turning on the left? I have more earth visible on the left hand side, less earth visible on the right hand side. Horizon is kind of slanted, right?
Horizon. This is especially useful when the natural horizon is obscured by clouds, the visibility is poor, or when flying.
So when you study regulations, you'll come across which VMC, IMC, IFR, VFR. When you're doing IFR, you are actually looking at these artificial horizon kind of instruments instead of relying to the natural light and the natural horizon. Understood?
At night. Along the outer rim are tick marks to indicate bank at the 0, 10, 20, 30, 60, and 90 degrees angles of bank. Degrees of pitch are located both above and below the artificial horizon in either 5 or 10 degree increments. At the top of the instrument is a small triangle that points to the correct bank angle the plane is in. The center of the miniature airplane lines up with the current pitch the plane is in. The gyro in this instrument spins.
Any doubts as of yet? समझ आया? Same चीज जो मैंने बोली वही इसने बोली है, right?
Around the vertical axis, meaning that the gyro.
Look at this. The gyro has a vertical axis. This is the rotor rotating at a very high speed.
Rotates level with the horizon. The two get.
Look, I'm gonna just reduce the speed a little bit. Okay. Now look at the
holding
working.
The gyro allow the gyro to move freely.
Look at the working
and maintain its level or increments.
What working is going to be shown over here, look at it. When an aircraft pitches nose down, so look at this. Can you see me? Yes. So let's say this is the artificial horizon's axis. Okay. And this is my aircraft. This is the axis, this is the aircraft. If my aircraft pitches down, this axis is going to remain here. But I am looking at the horizon at this angle. I'm looking at the horizon at this angle. Everyone gets this? Am I going nose down or nose up? It's nose down. I'm looking at it from this angle. When my aircraft is going like this thing will still stay rigid in space. I'm looking at it from this angle. Am I pitching up? Yes, I'm pitching up. Cool. Now look what happens to the moving card. Look what happens to the moving card inside this video. The moving card, the small little card that I told you, look at what happens to the moving card.
At the top of the instrument is a small triangle that points to the correct bank angle the plane is in. The center of the miniature airplane lines up with the current pitch the plane is in. The gyro in this instrument spins around the vertical axis, meaning that the gyro rotates level with the horizon.
Now,
the two gimbals holding the gyro.
Okay. You see a 3-fold sandwich over here. You see 3 things. An outer ring, an inner back card. In the middle, you have a moving card. In the middle, you kind of have a moving card. The moving card has gone up or has it gone down? Up. So what does that mean? In relation to the original horizon, I'm seeing more of the ground, right? Look at this. My aircraft is going in this direction. It's going in a top-down direction, right? You're seeing the instruments from that way. This is the original axis, right? Understood? Not understood? The card moved up. The mechanism is such connected that when you actually pitch down like this, the card moves up and you see a lower pitch.
Allow the gyro to move freely and maintain its level orientation as the airplane.
This is the hinge. Okay.
Plane maneuvers. Connections to the instrument face will then show the aircraft's attitude to the pilot. Note that if the airplane is experiencing an excessive pitch or bank, or if vacuum pump is not providing enough suction to spin the gyro, this instrument can read inaccurately. Heading indicator.
Any doubts? It's a great video, right?
No.
You were able to visualize it. Yes, Anushka, tell me.
No, nothing, sir. No doubt.
Cool. समझ आई बात क्या कहना चाह रहा था वीडियो? The reason why I showed you this video, you will be able to analyze and visualize the thing like really, really well. One thing that he has not explained is the working of the pendulous vanes. In the DGI, I explained to you how is toppling prevented. The same kind of toppling is prevented in an artificial horizon with the help of pendulous vanes, and the working of this pendulous vanes is towards the complex side. You might know the entire thing. DGI में जैसे अर्थ रेट समझना थोड़ा मुश्किल था, यहाँ पे पेंडुलस वेन्स की वर्किंग समझना थोड़ा मुश्किल है. Okay, figure not, we're gonna teach nice works. We have the artificial horizon. Which indicates us what? The artificial horizon gives us what? Attitude. Attitude indicator. It indicates us the attitude. Write down. And what is attitude? Attitude is a mixture of pitch, and it is a mixture of roll or bank, right? What kind of a gyro it is? It is a earth gyro. It is a earth gyro. And this earth gyro is a part of tide gyro, right? Earth gyro is a sub-classification of a tide gyro. And this is tied to what? It is tied to something. It is tied to the earth's vertical. It is tied to the earth's vertical. How is it tied to the earth's vertical? By using the earth's gravity. How? By you make the bottom of the rotor heavy. Okay? You make the bottom of the rotor very heavy. Understood? Okay. How is it attached to the earth's vertical? It is attached or tied to the earth's vertical by keeping the bottom of the rotor very, very heavy, and by using, so now let's say this is vertical. What if it topples? What if it topples? What if it topples? How are you going to prevent it? To prevent topple, you have pendulous vanes. Okay. Okay. Let's talk about the gyro. The construction and the working. कंस्ट्रक्शन में अगर मैं पहली बात आऊं, कैसा टाइप का जायरो है? इट्स अ वर्टिकल जायरो. एयर ड्रिवन. Easy. Right? The diagram is sent in the group. Have a look. Okay, so let's say we have a gyro housing. Okay, let's say this is the gyro. This is the rotating gyro, and this is only the rotating part. Okay, guys, Mark my words, this is only the rotating part of the gyro. But below the gyro, this is the axis, right? But below the gyro, there is a fixed part. Okay, this is a rotating part. This is a fixed part. And this fixed part contains the pendulous veins. This is the fixed part which contains the pendulous veins, kind of like this. It's fixed. But this axis is connected to a gimbal. Okay, I'm just going to get rid of the rotating and the fixed part. The fixed part is going to be drawn here though. I'm going to show you the gimbals. Let's say I have this is the first gimbal. Okay, works. This is going to give me freedom in around the normal axis, right? Now I'm going to get you another one. I'll take another color. Okay. Now I can rotate it kind of like this. ऐसे भी कर सकता हूं. I have now freedom in pitch. Now have a look. Here's the deal. This thing, this outer gimbal is connected. Okay. So now this thing can move in pitch. This thing can move up and down. This outer thing, this outer gimbal is the part which contains, this outer gimbal is the part which contains this card, this moving card. Okay. Okay. This outer gimbal is the thing which contains the moving part. Okay. So the outer gimbal contains the moving card. So now let's say you pitch down. When you pitch down, this gimbal goes up from here. Okay, I'll just take this card away. This gimbal, when you pitch down, what happens to the outer gimbal? This green gimbal, this gimbal goes up like this and this comes up like this, right? Right? Yes or no? And because this goes up, it was like this and it goes up, you see more of the ground, right? Why do you see that? Because there has to be a gull wing. The gull wing is kind of attached to the glass like this. The gull wing is attached to the glass kind of like this. Okay, and it is separate. Understood or you did not understand? You understood, right? So when this thing moves up, the gull wing actually, when the pilot sees it, the gull wings is shown like this, like it's on the bottom side, on the ground side. That means it's a pitch down. It's easy. The mechanism of working is easy, right? Now, what if you were to pitch up? So then what would happen? Then this thing, this outer gimbal, will move down like this and this will go up over here. As a result, this entire card is also going to move down, and the gull wing, because of the gull wing is going to stay here. You will be shown a pitch up. The same thing is given in your notes like so. Have a look. You saw the diagram that I sent in the group? You are successfully able to see how is the rigidity of a certain rotating mechanism able to give me a displacement. I can easily calculate a displacement, right? So hence a displacement gyro as well. I now explained you how does pitch work. We haven't yet explained you how does rolling work. Pitch समझ आ गया, rolling नहीं समझ आया. Ab look at this. This is the gull wing that is connected to the aircraft. This is the gull wing that is connected to the aircraft, right? Or let's say this is the wing. This is the gull wing itself, right? The gull wing and the wing is the same. Wherever the aircraft is going to go, the gull wing is also going to go like that, right? But this is the artificial horizon's axis, right? If this is the axis of the artificial horizon, there is a card, a blue part and the brown part, right? And between the blue part and the brown part, we will have an horizon, right? So now let's say the pilot is over here. The pilot is over here, and this thing is the horizon of the instrument. This is the gull wing. The horizon is going to stay stationary and the aircraft is going to rotate like this. What is going to happen? What is going to happen? Look at this. What's going to happen? Perfect. The gull wing is attached to the aircraft, right? And this entire thing, guys, this entire thing is stationary. अगर ये खड़ा है तो खड़ा ही रहेगा, right? ये खड़ा है तो खड़ा ही रहेगा. अगर वो कार्ड ऐसा है, horizon ऐसा है तो ऐसा ही रहेगा, right? Great. Now, what did you do? You banged the aircraft to the left. What is going to happen? Because this gull wing is connected to the outer casing, when that outer casing is connected to your aircraft bangs to the left, your gull wing also bangs to the left. And because your gull wing bangs to the left, is a left bank shown? Is a left bank shown? Yes. मेरा एक्सिस ऐसे, ये मेरा एयरक्राफ्ट, अगर मैं बैंक करूंगा, अगर मेरा एयरक्राफ्ट बैंक करेगा, मुझे इंडिकेट हो जाएगा, बिकॉज जो मेरा गल विंग है, वो गल विंग भी एयरक्राफ्ट के साथ टर्न हो रहा है. एनी डाउट्स? नो डाउट्स? Great. Just like the DJI was limited to certain degrees of pitch and certain degrees of roll, the artificial horizon is also limited. Okay, the artificial horizon is also limited. The limitations are sent in the group. Please have a reading at these things that are sent in the group right now. As you can see over here, the maneuver limitations. Okay, have you read the roll part? Roll part is the exact same thing what I taught you. Any doubts here? Everything crystal clear? I think it's clear. Maneuver limitations. So if you look at pneumatic and electric, pneumatic is telling you that if you go plus 60 degrees in pitch, minus 60 degrees in pitch, I will be able to show you good indications, no problems. And I will be able to show you this is 90 degrees of bank. This is 111 degrees of bank. Till here, I will be able to show you everything. Otherwise, after that, I'm gone. This is my limitation. This is my area of operation. And this 60 degree minus 60 degree. Okay. But in the case of the pneumatic, I can indicate, in the case of an electric one, correct pitch will be indicated till this big of an angle and this less of an angle. And there is a complete freedom in roll. There is a complete freedom in roll. What kind of artificial horizons are used in my aircrafts? For example, let's say a Cessna, an air-driven one is used. But let's say if I were to fly a fighter jet who has to do all different kinds of stunts and everything, do you think I will use an air-driven one? I won't. Do you think an aerobatic aircraft will use an air-driven artificial horizon? I don't think so. Any doubts? No? Easy? Great. So मैंने आपको यहाँ पे construction बता दी, इसको move करके आपको मैंने system बता दिया इसका. Now I'm going to teach you how do we keep it tied. How do we keep it tied? Tied is done by keeping it bottom heavy. Now have a look at this. This is the gyro's axis and this is the rotating part of the gyro. This entire big assembly is the rotating part of the gyro, and it rotates in this direction. If you look at from the bottom side, it looks clockwise. If you look at it from the top, it looks anti-clockwise. Exam में क्या पूछा जाएगा? Top anti-clockwise. Cool. Top anti-clockwise. So how is air drawn? Air is drawn around here. It rotates the entire assembly, and air comes in into this little chamber below this rotor, and this is a fixed chamber, and this fixed chamber has air escaping out from it through 4 veins. It has air escaping out via 4 veins. So 360 degrees का उसका सरफेस होगा, राइट? यहाँ पर वेन्स रहेंगे. वेन्स अभी मैं आपको ड्रॉ करके दिखाता हूँ कैसे दिखते हैं. ये देखो. तो यहाँ पे लेट्स से एक विंडो है, ठीक है? वी हैव अ विंडो ओवर हियर, एंड यहाँ पे मैंने एक छेद बना दिया, एंड इस छेद पे मैंने कुछ ऐसे टाइप का ढक्कन बना दिया. इट्स अ सॉलिड ढक्कन. Okay, so this guy is like free to rotate. It can become like this also. It can become like this also. It can rotate. Cool. So if I were to explain it to you, it's like ये कुछ ऐसा ही है. ये रोटेट करके, ये ऐसे रोटेट करके इस पूरे एरिया को कवर भी कर सकता है. होता क्या है, when this rotor is rotating, we are continuously sucking air, and air is driving it, and it is coming out. It is coming out of these holes. These holes. Any doubts? And below this entire thing, you have a very, very heavy mass attached, kind of like a Beyblade. A Beyblade stick, right? This is basically an iron mass. Why? It is an attached weight so that we can keep it bottom heavy. If it tilts, it's going to come back somewhere or the other, sooner or later, right? After precessing a little bit. No doubts? Now I'm going to look at this gyro from a top-down perspective. Okay, my eyes are going to be over here, and I'm going to look at it from a top-down perspective. The entire gyro will look to me like this. This entire chamber will look to me like this. ठीक है? तो अब ये स्क्वायर में we have 4 holes on 4 sides. And each of these 4 holes is connected by a parda, is covered by a parda. Halfway, 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 halfway. And they are like just, screw, and they are like freely as a dangling. Ding, ding, ding. They can dangle. They can cover it, they can not cover it. हाँ भाई ताली बजा रहा है.
जल्दी से हो गया भैया.
So they can either cover the entire hole or they can not cover the entire hole. It's that simple. In normal flight, air is coming out here, air is coming out here, air is coming out here, and air is coming out here. All the forces are balanced. All the forces are balanced. Okay. So first thing, I've kept the weight heavy, and this heavy weight is going to keep my vertical thing straight. This is how I tie it down. This is how I tie it down. Any doubts? No. Now let us, in the DJI we did, okay, there is a topple, how do we prevent it? Okay, let's say the gyro kind of toppled like this. The gyro axis, the gyro toppled like this. Instead of the axis being like this, the axis became like this. It toppled in this direction. If it toppled in this direction, this thing is like the very same, this chamber only, this very chamber, but you're looking at it from top down. If it actually topples in this direction, do you think that This pendulous vein will come and cover this. Yes. वैसे गिर जाएगा, कवर कर देगा, एंड ये वाला पीछे हो जाएगा. Correct? Any doubts here? Do you think this and this will be affected? Do you think these two will be affected? No. Equal forces, equal forces. Right? Right? Or no? So, look what's happening. Now more air is coming out of here. Air is not being able to go there. You getting it? तो ये हवा क्या करेगी, इसको यहाँ से ऐसे पुश कर रही है, अंदर के पूरे चेम्बर को यहाँ पे पुश कर रही है. If air is coming out over here, it will put a reaction force on the chamber. It will put a reaction force on the chamber here. But do you think this reaction force will act in this direction? It's a fucking gyro. No. This force, look where it is rotating. It is rotating like this. So this force will also get rotated. Instead of acting like this, it will also rotate in this direction. It will also rotate in this direction and act like this. So the air which was coming out over here, I'll just clean up the diagram a little bit. So this thing is tilted, right? Air which was coming out over here, it gave it a reaction force to the bottom of the gyro. To the bottom of the gyro, it gave a reaction force inside the screen. It got turned around and it gave a force to the gyro in this direction, right? After the precession thing. So now the gyro which was toppled like this, it is getting a force from the below like this so that it can again re-erect. How beautiful of a mechanism, right? How beautiful of a mechanism. So guys, I'll just keep your life very simple. I'll just keep your life very simple. I'll ask you a genuine question. You want to get into the depths of errors and understand how do the pendulous veins change directions and cause the error? Or do you want the easy way out where you just learn what's required to be done? Which one do you want?
Easy one for now.
Second.
No issues. कभी भी डीप में जाके समझना, एक बार इसको रीड भी कर लोगे ना, इसके बाद वाला पार्ट जो है नोट्स में समझ आ जाएगा वो पेंडुलस वेन्स कैसे अरेंज करनी है खुद को. ठीक है? फॉर द पर्पस ऑफ योर एरर्स ऑफ योर आर्टिफिशियल होराइजन, you just need to remember two things. Whenever you accelerate, it will show a pitch up and left bank. Whenever you decelerate, it will show you a pitch down and a right bank. As you can see, it's about talking about acceleration and deceleration. So this error is called the acceleration error. Understood? Turning error. You just have to remember this table. Just like you've drawn this thing, I want you to draw this table which is sent in the group right now. Okay. The next question that might be asked from this particular chapter is about the electrical artificial horizon. When you have an electrical artificial horizon, what do you have? You have torque motors and everything. Why do you need an electrical artificial horizon? It provides you greater rigidity. more stable RPM. Okay, and here the torque is measured on the gimbal force. So okay, there will only be 2 questions. I'm giving it to you way before. इसको लेके 2 जगह से क्वेश्चन आते हैं. Add these 3 things in your notes and you'll be taken care of.